Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's intensive math class. Today we're going to talk about the last section of our whole numbers unit. And we're talking about GCF and LCM. And not only is this very important for whole numbers, but it is going to be extremely important for when you are doing fractions, when you're adding and subtracting, in particular, fractions and mixed numbers. If you don't know how to find the greatest common factor or the least common multiple, you're in big trouble. So let's make sure that we really understand it. I want to take my time, and I want to make sure that you guys master this. Now, first things first, my brothers, the GCF. The GCF is called the greatest common factor. And what does that mean? That means that of all the factors of a number, the GCF is the largest factor that two or more numbers share. That's all this is. The greatest common factor is the largest factor that two or more numbers share. Now the question may be, okay, that's great, Mr. Moore, but what is a factor? Well, a factor is a number that goes into or divides evenly into another number. In other words, it's a number that divides another number without a remainder. Okay? So a factor is a number that divides evenly into another number without a remainder. A couple things about factors. Factors are always less than or equal to the original number. Factors are always less than or equal to the original number. And every single number always will only have a set number of limited factors. Factors are not infinite. They do not go on forever and ever. There is only a particular number of factors for each whole number out there. For example, why don't we list all of the factors of each of the numbers here? The way that I like to train my students to do this is to start with the number 1 and then you end with the number 10. What am I talking about? Okay, does 1 go into 10? Okay, and isn't it 1 times 10? So give yourself plenty of space, put a 1 at the beginning and a 10 at the back. Does 2 go into 10? 2 times what? So put a 2 in the front and a 5 in the back. Does 3 go into 10? Does 4 go into 10? Does 5 go into 10? Yes, but we already have it. Does 6 go into 10? Does 7 go into 10? Does 8 go into 10? Does 9 go into 10? Does 10 go into 10? But we already have it. So, once we have that, we can rewrite it to make it nice and neat. 1, 2, 5, and 10. Notice that what I had said before is true. Okay? If I look at this, factors are always less than or equal to the original number. Is 1 less than or equal to 10? Guys? Yeah. Is 2 less than or equal to 10? Is 5 less than or equal to 10? Is 10 less than or equal to 10? Also remember that I said every number only has a set number of limited factors. There were only 4 factors for the number 10, weren't there? That's what I mean by a limited number of factors. Does that make sense, gentlemen? All right. This is awesome then. Let's continue, my brothers. How about for 12? Let's start again like I did before, starting with 1. Does 1 go into 12? 1 times what? So put a 12 back here. Does 2 go into 10? 2 times what? Excellent. Does 3 go into 10? 3 times what? Does 4 go into 10? Yes, but we already have it. Does 5 go into 10? I'm sorry, 12. I'm sorry, I'm saying 12. Sorry. Thank you, my brother. Start that again. 1 times 12 is 12. 2 goes into 12 because it's 2 times 6. 3 goes into 12 because it's 3 times 4. I really apologize. Thank you. Does 5 go into 12? No. Does 6 go into 12? But we already have it. Does 7 go into 12? Does 8 go into 12? Does 9 go into 12? Does 10 go into 12? We're done. How about 25? Does 1 go into 25? Yes, 1 times what? 1 times 25. Awesome. Does 2 go into 25? Does 3 go into 25? Does 4 go into 25? Does 5 go into 25? 5 times 5, but you just have to put it one time. Does 6 go into 25? Does 7 go into 25? Does 8 go into 25? Does 9 go into 25? Does 10 go into 25? So my factors of 25 are only 1, 5, and 25. How about 30? Does 1 go into 30? Yes, 1 times 30. Does 2 go into 25? Does 2 go into 30? I'm sorry. 2 times 15. Beautiful. Does 3 go into 30? Yes, 3 times. Excellent. Does 4 go into 30? Does 5 go into 30? Yes, 5 times what? Awesome. See how knowing the multiplication tables helps you? Does 6 go into 30? Yes, but we have it already. Does 7 go into 30? Does 8 go into 30? Does 9 go into 30? Does 10 go into 30? Yes, but we already have it. Is this making sense, my brothers? Okay. How about 80? Does 1 go into 80? Yes, 1 goes into 80. 80 times. 1 times 80. Does 2 go into 80? Okay. 2 times what? 2 times 40. Very good. Does 3 go into 80? Does 4 go into 80? Yes, 4 times 20. Very good, very good. Does 5 go into 80? Yes. How many times though? 5 goes into 80. It's 5 times 16. 5 times 16 is 80, guys. 16 times 5. You got a 0. Carry the 3. That's 80. Does 6 go into 80? No. Does 7 go into 80? No. Does 8 go into 80? Yes. 8 times what? Very excellent. Does 9 go into 80? Does 10 go into 80? Yes, but we have it already. So that is how you list factors. Okay? Now, to help you out here, you can look at just about any number and find out if a number goes into that number by using what's called the divisibility test. In order to help you recognize factors quickly, it is important to know the divisibility test as shown below. And the way we read this table is like this. A number is divisible by, and then I have this line, if, and then I have the requirement. So a number is divisible by 2 if the number ends in a 0, 2, 4, 6, or 8. So in other words, if it's an even number. So numbers like 344, that is divisible by 2. That will be one of the factors. 86, that's an even number. It's going to be divisible by 2. If I have 74, that is an even number. So you're going to go ahead and say, yes, that is divisible by 2. Please write down what I'm writing down, my brothers. That is part of taking notes. Thank you. Our number is divisible by 3. This is a very, very important one. If the sum of the digits is divisible by 3, what am I talking about? Let's look at the number 18. We know that 3 times 6 is 18, but let's see how this test works. The digits here are 1 and 8. What's 1 plus 8? 9. Is 9 divisible by 3? So 18 is divisible by 3. What if I gave you the number 909? What's 9 plus 0 plus 9? 18. Is 18 divisible by 3? So 909 is also divisible by 3. Does that make sense? Okay. A number is divisible by 4 if the last 2 digits of the number are also divisible by 4. For example, let's say I give you the number 316. You look at the last 2 digits. Are the last 2 digits, which is 16 here, is that divisible by 4? So 316 is also divisible by 4. What if I give you a crazy number like 52,728? You look at the last 2 digits. And is 28 divisible by 4, my brother? Yes. So is this whole entire number divisible by 4? Yes. 5 is an easy one. A number is divisible by 5 if the number ends in a 5 or a 0. So any number that ends in a 5, or a 0 is divisible by 5. Like 55, or 100, bless you, and 5, or 30, or 2,000, or 1,005. Any number that ends, any number that ends in a 0 or 5 is divisible by 5. Now, bless you. How about 6? A number is divisible by 6 if the number is divisible by both 2 and 3. For example, the number 12. 12 is an even number, so we know it's divisible by 2. But what is the sum of 12, of the digits of 12? What's 1 plus 2? 3. Is that divisible by 3? Yes, so we know that this number is divisible by 6. How about something like this? Let's do a little bit of a larger number. Let's do 414. That's an even number, so is it divisible by 2? Absolutely. Now, what's 4 plus 1 plus 4? No, what's 4 plus 1 is 9. Is 9 divisible by 3? So if a number is divisible by both 2 and 3, it is divisible by 6. Does that make sense, my brothers? You promise? Okay, now, the sum of the, for number 7 and 8, there are rules for it, but they're so complicated that it's easier just to test the number out. So if you want to know if a number is divisible by 7, go ahead and divide it. If you have no remainder, then it is divisible by 7. If you want to find out if a number is divisible by 8, just divide the number by 8. If there are no remainders, then you know it is divisible by the number 8. Let's look at the test for number 9. A number is divisible by 9 if the sum of the digits is divisible by 9. Very similar to 3. So for example, what if I have 405? What's 4 plus 0 plus 5? Exactly, 9. Is 9 divisible by 9? So it works. What about if I gave you 700, let's see, actually, let's do 7-1, and then let's do 2, that's going to be, okay, perfect. What's 7 plus 1 plus 2 plus 8? 18, very good. Is 18 divisible by 9? Very good, my brothers. So that means that 7,128 is divisible by 9. And last but not least, a number is divisible by 10 if the number ends in 0. Does that make sense? Okay, so now, let's do some practice here. Let's list all of the factors of 48. But when we're going through the factors this time, we don't have to guess anymore. We can use our divisibility test to see if it goes in or not. So, for 48, definitely 1 times 48, correct? Okay. Now, does 2 go into it? How do you know? Because it's an even number. Very good. 2 times 24 is 48. Beautiful, gentlemen. Does 3 go into 48? Why? How do you know? No. How do you know for the divisibility test? What's 4 plus 8? 12. So that's divisible by 3, so it is divisible by 3. And yes, you're correct. It's 3 times 16. Does 4 go into 48? Yes, because the last 2 digits are divisible by 4. It'd be 4 and 12. Does 5 go into 48? How do you know it's no? Thank you. It doesn't end with a 0 or 5. Does 6 go into 48? How do you know? No. 6 times 12 is not 48. How do you know for the divisibility test that 48 is divisible by 6? Excellent, sir, because it's divisible by both 2 and 3, guys. And it's 6 times 8 is 48. Is 48 divisible by 7? No. You know that because 7 times 7 is 49. Nothing times 7 is 48. Does 8 we already have? Does 9 go into 48? How do you know? What's 4 plus 8? 12. Is 12 divisible by 9 evenly? No, so 9 doesn't work. These are all the factors of 48. You with me? Okay, my brothers. How about 60? We know it's 1 and 60 for sure. Oh, and I'm sorry. Does 10 go into 48? How do you know? It doesn't end in a 0. Great. Okay, does 2 go into 60? Yes, because it's an even number. 2 times 30. Does 3 go into 60? Yes, because 6 plus 0 is 6, which is divisible by 3, and it's 3 times 20. Does 4 go into 60? The answer is yes, guys. You got to know your 15 tables, which we've been practicing. It's 4 times 15. Does 5 go into 60? Yes, because it ends in a 0. 5 times 12 is 60. Does 6 go into 60? Yes, because it's divisible by both 2 and 3, and it's 6 times 10. Does 7 go into 60? No. Does 8 go into 60? No. Does 9 go into 60? No. 6 plus 0 is 6. 6 is not divisible by 9. And does 10 go into 60? Yes, because we have it. Now, where we're going from here, guys, is the whole point of this is the greatest common factor. What factor is the greatest common factor between 48 and 60? What is the largest factor that both of them have in common? Sir? No. How is 60 the largest factor that is common to both 48 and 60? Yes, sir. 12. Very good. So in this particular case, my GCF, my greatest common factor, would be 12. Does that make sense, guys? You promise? Awesome. May I continue? Okay. Now, we're going to have to learn about prime numbers and composite numbers. Okay? A prime number is very important. A prime number is a number whose factors are only 1 and itself. In other words, a prime number is a number that is only divisible by 1 and itself. This is a concept that you really want to learn and understand. Let's look at some of the prime numbers because there's an infinite amount of prime numbers. 2 is prime because only 2 times 1 gives you 2, no other factors. 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. These dots mean etc., etc. Keep going on forever. Well done. So prime numbers are numbers that are only divisible by 1 and itself. Prime numbers are numbers that are only divisible by 1 and itself. Now, the opposite of that is called a composite number. And a composite number is a number that has more than two factors. Actually, this is wrong. 2 is not composite. Sorry. That was a mistake. But 6 is composite. 8, 9, 10, 12, 14, 15. Because all of these numbers have more than 2 factors. The factors of 6 are 1, 2, 3, and 6. The factors of 8 are 1, 2, 4, and 8. The factors of 9 are 1, 3, and 9. The factors of 10 are 1, 2, 5, and 10. The factors of 12 are 1, 2, 3, 4, 6, and 12, etc., etc. So prime numbers only have factors that are 1 and itself. Composite numbers are numbers that have more than 2 factors. I want you to please notice, though, that 1 is neither prime nor composite. No, it's neither prime nor composite. Because think about it. Prime number is a number that is divisible by 1 and itself. But 1 is itself, so it is not prime. And 1 is not composite because it does not have more than 2 factors. 1 only has 1 factor, 1. So 1 is neither prime nor composite. Now, we use prime numbers in order to break down larger numbers into what is called prime factorization. And prime factorization is when you break down a number into its prime factors. For example, find the prime factorization of 120. The good news, you can start anywhere you want. Okay, my boy wants to start with 2 times 60. Every time you break down a number, circle the prime number. Are either one of those prime? Yes, which one is prime? The 2. So circle it. 60 can break down into 2 times 30. Very good. 2 is prime. Circle it. 30 can break down into 2 times 15. 2 is prime. And 15 can break down into 3 times 5. And both of them are prime. That is the prime factorization of 120. It means that these are all of the prime factors of 120. After you've figured out your factor tree, your answer will be written like this. How many 2's are there? So it's 2 to the third power times 1 3 times 1 5. And that is my answer. You do not have to multiply them, because if you multiply them, you go back to the 120. Does that make sense, my brothers? Okay. May I continue, my brothers? Okay. Now, you can also use prime factorization in order to find the GCF of 2 or more numbers. Don't get me wrong. If you wanted to, you can list all the factors of 36. You can list all the factors of 100. And then you choose the greatest common factor. Or you do it a much better way. Break down 36. This is 2 and 18. Circle the prime. This is 2 and 9. Circle the prime. This is 3 and 3. Circle the primes. I got nothing else to break down. Let's break down 100. 2 times 50. 2 times 25. Circle the prime. And then 25 is 5 times 5. Circle the primes. Now, your GCF, my friends, is the product of matching pairs from one side, bless you, to the other. So it's the product of matching pairs from one side to the other. Please pay attention to what this means. You see how on the left side I have a 2? And on the right side I have a 2? That's one pair, correct? So it comes out as 1, 2. Times. Do you see how I have another 2 on the left side? And another 2 on the right side? That's another pair, so it comes out as 1 of that value. Do I have 2 3's on both sides? No. I have 2 3's on one side, but do I have it on opposite sides? Do I have 2 5's on opposite sides? So my answer for the GCF here is 4. Yes, the GCF is the product of the pairs from one side to the other side that you pull out. Does that make sense, gentlemen? Okay, let's do another one. Please. Okay, 120 and 80. 120 can break down into 2 times 60. 60 can break down into 2 times 30. 30 can break down into 2 times 15. 15 can break down into 3 times 5. Prime, prime. I'm done. There's nothing left to break up. 80. 80 can break down into 2 times 40. 40 can break down into 2 times 20. 20 can break down into 2 times 10. And 10 can break down into 2 times 5. Go ahead, please, and write those down, and then we'll figure out the GCF together. But I want to make sure you got this all down. Okay. So the GCF here, remember guys, is the product of the pairs of prime numbers that you pull out. So, follow me please. I'm going to do a different color so you could see it clearly. Okay. A 2 and a 2 comes out as, no, as 1, 2. Every pair comes out as one of that value. Another 2 and another 2 comes out as a 2. Another 2 and another 2 comes out as a Another, oh, do I have another 2 on both sides? Do I have a 3 on both sides? Now, do I have a 5 and a 5? So that comes out as 1, 5. So my GCF, 2 times 2 is 4, times 2 is 8, times 5 is 40. Very good, my brother. And that's how you find GCF. Any questions, my friends? How did I get 40? What's 2 times 2? 2 times 2 is 4. Times 2 and times 5? Thank you for asking, man. That's my job, sir. Okay. My question is, why didn't I take, do I have a 2 on both sides, brother? Another 2 on both sides? Do I have another 3 on both sides? So you do not touch those. You only pull out pairs of values as one of that value. A 2 and a 2 came out as a 2. A 2 and a 2 came out as a 2. A 2 and a 2 came out as a 2. A 5 and a 5 came out as a 5. I do not have a 3 on both sides. I do not have an extra 2 on both sides. Does that make sense? Thank you, my brother. Okay, guys, we're almost done. Now, the least common multiple. Multiples are different than factors. They're actually the opposite. Multiples are the product of one whole times every other whole number. Multiples are always greater than or equal to the original number. And every number has an infinite number of multiples. So for example, 6, I'm asking you to list the first 10 multiples of 3. Well, this is easy. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Why did I put 14? 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. 3 times 10 is 30. Those are the first 10 multiples of 3. So you find multiples by starting with 1 and multiplying by every single whole number. Does that make sense? Okay. Now, you can also use prime factorization for finding the LCM of 2 or more numbers. And let me give you the formula for it right now. LCM equals the GCF times the left over prime numbers. The LCM equals the GCF times the leftover prime numbers. Let me explain what I mean. Find the LCM of 18 and 20. First, break it down. 18, that's 2 times 9. Prime number is 2. And then 9 breaks down into 3 times 3. Now let's break down to 20. This is 2 times 10. And 10 breaks down into 2 times 5. So there you go. I've broken it down. Now, in order to find the LCM, we've got to find the GCF. So what's the GCF here, guys? You have a 2 and a 2, which comes out as a 2. Do I have a 3 on both sides that I can pull out? Do I have an extra 2 on both sides that I can pull out? Do I have a 5 on both sides that I can pull out? So GCF is 2. So what's my LCM, Mr. Morrow? Very easy. It's the GCF, which is 2, times the leftover primes, which would be a 3, another 3, a 2, and a 5. And now you just multiply them. 2 times 5 is 10. 10 times 3 is 30. 30 times 3 is 90. 90 times 2 is 180. And that, my brothers, is how you find the LCM. Does that make sense, gentlemen? Okay? Give me 1 second, please. Okay, thank you. All right. Let us do one last example then for today. Let's find the LCM of 12 and 40. So we first break down 12. 3 times 4. Circle the prime, 3. And then 2 times 2. Circle the primes, 2 and 2. 40 is 2 times 10. Circle the prime. And then 2 times... Whoa, that's wrong. That's wrong. That's wrong. No, I'm going to put 2 times 20 is what I meant. Sorry. Thank you. 2 times 20. And then 20 breaks down into 2 times 10. Circle the prime. And then 10 breaks down into 2 times 5. Circle the prime. Oh, whoa. Circle the prime. Circle the prime. In order to find the LCM, you first need to find the GCF. So my greatest common factor here, a 2 and a 2 comes out as a 2. Another 2 and another 2 come out as 1, 2. So my GCF is 4. My LCM is, hold on, not yet. My LCM is the GCF, which is 4 times the leftover primes. So 4, which is my GCF, times a 3, times a 2, times a 5. And we'll finish in a second. Okay, guys, so like I said, you have the LCM of 4 times the leftover primes, which was a 3, a 2, and a 5. 4 times 3 is 12, times 2 is 24, times 5 is 120. And that is my LCM. And that is the lesson. I hope you guys learned a lot. Thank you for a great class and have a wonderful day.